Good morning friends. Today we are going to study the control wall classification. Before studying the classification, we must know what is control wall. We must know what is its application in industries. Here a schematic diagram of control wall is available. It consists of a diaphragm, then a spring, then a stem, then position indicator, then a plug. And through the body of this wall the flow transmits from one point to another point. Actually, when air inlets is introduced from this top section, it will deflect the diaphragm in downward direction, which transmits the stem in downward direction, which actuates this plug and which controls the flow of the fluid. The control valves are generally used in process industries for controlling the flow of various fluids like water, other liquids, other gases, air. First, the classification of this control valve based upon the various parameters. The first parameter of this classification is the control action, means classification based on control action. Here we have two types of control valves. First is air to open control valve and second one is air to close control valve. What is basic difference between these two types of control valves? If we see at this plug of the control valve, it is actuated by the spring and diaphragm. Here the load means air is introduced and vent is provided. In this case, air is introduced from top side and vent is provided at bottom side. When air is introduced in this diaphragm or this compartment, the diaphragm will move in upward direction. When the diaphragm will move in upward direction, then this plug will move in upper side. So therefore the valve will be in open position. Therefore it is called as air to open valve. In second diagram, the load, that is air, is introduced in top section and vent is provided in bottom section. When air is supplied from top section, the diaphragm will move in downward direction. So downward direction movement will produce this plug to block the opening for the flow. Therefore, as the air is introduced, the plug will be closed and flow will be stopped. Therefore, it is called as air to close type control valve. These air to open or air to close control valves are used in industries depending upon the level of application. That is, if we consider an exothermic reaction. What is the exothermic reaction? The reaction in which heat is generated as the reaction progresses. In this case, suppose in exothermic reaction the material or air is blocked. Suppose the air supply is blocked, then what will happen? If we use, in this case, air to open type valve, control valve, then if the supply of air is blocked, then the valve will be at closed position, means no fluid or no fluid material will be transferred to that reaction vessel. Simultaneously, for same exothermic reaction, the coolant is required. Therefore, if we use air to close type of control valve for coolant, then as the air is locked, therefore the valve will be at closed position. So depending upon the application, this type of valves are used. Second type of classification depends upon the number of plugs. Plugs mean the opening of the valve. So here the schematic view of globe valve is provided. In first type, the globe valve is single seat globe valve, means here only one plug is provided. In second diagram, the double seat globe valve is used, where two plugs are used in that globe valve. Next, classification depends upon the flow characteristics. There are three types of characteristics, that is linear opening valve, equal percentage valve and quick opening valve. What is difference between linear opening, equal percentage and quick opening? If we plot the graph of percentage opening of the wall and the flow rate. Then in linear opening wall, the graph between percentage opening and the flow rate will be in a straight line, means it will be in diagonal direction. In equal percentage wall, the graph, same graph, will be in curve form, and in quick opening wall, the graph of steam opening position, opening of the wall and the flow rate will be initially linear up to 1/3 part, then it will be in the curve form. So therefore, based on the flow characteristics, the walls are classified as linear opening wall, equal percentage wall, and quick opening wall. Third type of classification based upon the construction of the wall. So depending upon the construction of wall, there are 7 types of control walls: gate wall, globe wall, diaphragm wall, angle wall, butterfly wall, and rotary wall. So for today it's all. Thank you very much. Be connected, be safe.